This is chapter 16, example 1. The issue here is we're designing decoders, and all we need to do is come up with a table. And the idea is once we come up with that table, we can easily model it using an HDL. So we're stopping at the table. So this is very similar to brute force design, and you'll see the similarity. So it is kind of limited in what it can do. So the issue in real life is if you have a huge table, certainly you don't want to do it by hand, but it's really kind of straightforward to have a computer generate the table for you, or there are some looping constructs and HDLs that allow you to do something similar. But this is a standard problem. We've done it before a couple times, but it's worth doing again. So this is essentially a validity checking module that would work with a ripple carry adder. Remember, the way I check for validity for ripple carry adders is I check the sign bits of the input operands and the sign bit of the result. Now the idea is we're looking at 3 different sign bits, which is going to be a table with 8 rows in it. 6 of those rows are going to be valid, 2 are going to be invalid. So the 2 invalid cases are when I have 2 inputs of the same sign and I get an output of a different sign. The 2 inputs are of one sign, same sign, and I get a result or summation of a different sign. That is a not valid answer. We can model this. Invalid output, I like calling these A, B, and S. And S generally means sum. So these are, once again, these are all sign bits from RCA. So this is going to set up a table. So here's my table. I know it's going to be valid everywhere except for these 2 cases where the inputs, so these are the inputs and this is the output. The inputs are the same sign, outputs of a different sign. This is not valid. These are the 2 non-valid rows. Everything else is valid. Now we did this in a previous problem. We actually used POS, wrote a POS equation for the zeros. We're going to call this a decoder. As is, we've defined a table completely. We're going to call this problem done.